Good morning, good afternoon, good evening, depending on where you are on this fast forward planet. Still wrapped in a pandemic. I'm sad to report, not that you don't know this. The vaccination gaps, both globally and here in the United States, remain big enough that the virus will have lots of running room to come up with clever new alternatives to Omicron, which is the current pestilence that's driving people crazy. There are signs of progress. Even a new vaccine, the Walter Reed Medical Center, the Army has developed a vaccine. It's in the final stages of testing that looks like it could work on any coronavirus going forward, which is, we'll see. It's not made headlines yet, but stay tuned. At the same time, it's an overheating planet because of human activities. We're wrapping the planet in a growing blanket of greenhouse gases, something I've been writing about for too long. I think journalists like me and like Jeff, you like to think your journalism can change things. Sometimes it can. You can get somebody fired. You can get someone indicted. You can change a business practice maybe a little bit, but global warming seems bigger than a story. And I think we both have been trying to come to grips with this. Me in my 34th year on this beat. I have not been to Antarctica. I've been there many, many times through the eyes and the data collected by scientists. I've been to the North Pole. I've been to the Arctic 3 other times. But there's a special quality to Antarctica. It's hugely consequential. It's huge. It's not one place. It's incredibly diverse. And so today we're launching what I call a new category of webcast and blog post I'll be doing called Watchwords. And we'll zoom in on words that have either become labels that have no real meaning. Climate emergency to me it's so big that it really doesn't mean anything until you dive in and say, who's the emergency? Who's this an emergency for? And what's the remedy? Energy transition is another one I'll be talking about on here. We're not in one yet. Globally, primary energy is still mostly fossil and it hasn't changed. Our use of fossil fuels is growing far faster than any transition to anything you would like. So we'll look at energy transition. Today, the word collapse comes up because of Antarctica. And scientists, as you'll hear, and the public kind of have different versions of what that means. When you think of collapse, it's like a building collapse. When a scientist thinks of collapse in a glacier, it can be a multi-century process. And how do we as journalists and how does the public, as the public sphere, deal with this going forward? It's a really important question. But today, I've got a fantastic group here to explore this, literally. Jeff Goodell, as I said, who's a Rolling Stone senior writer. What's your title there? Oh, sorry, you have to unmute.
Contributing editor.
Contributing editor, yeah. He's been covering climate issues for a very long time. I'll talk about his book, The Water Will Come, in a little bit. You had a Guggenheim. I assume there's a book coming next. Great to have you on the show because your work has really elevated the Antarctic instability more than any single journalist I know. So good to have you here today. And Karen Alley, who's moved recently to the University of Manitoba, a glacier-focused scientist and a fantastic hammered dulcimer player. I might close out the show with a little bit of a recording of you doing that. And I met you in Boulder, UC Boulder, I think, when you were getting your PhD. We jammed there.
Yeah.
But you're part of this international Thwaites collaboration. And speaking of which, Rob Larter from the British Antarctic Survey, who is one of the deputy science director for this really ambitious international initiative to dig in on the dynamics of this glacier. And
that sounds too grand. I'm the principal investigator of one of the 8 projects. I'm one of the principal investigators because there are 2 for each project.
Okay, well, I'll show a graphic in a minute, and you can go through some of those details. That's great. And he's been on Twitter very actively. One of the like me, one of the older folks who seem to actually like Twitter. So we'll talk about that too. And finally, Bethan Davies, who I first noticed your work on Antarctica in 2014 when I first wrote about this issue of collapse, words like this and what they mean and don't mean, and how we can have clarity for the public on risk. And I'll show some of your blogging and your work too. You're at the University of London, right? Holloway Holloway?
That's right. Yeah, Royal Holloway. Yeah, part of the University of London. That's right.
And right now you're in Chile. You're going to be exploring Patagonia's ice.
I am. Yeah.
Shortly.
Yeah, we're off into the field. We just arrived and we're off into the field tomorrow.
Fantastic. Well, let's go. I want to show a little video clip here from the British Antarctic Survey, I think.
One of the greatest challenges we face in the next century is the rising sea levels and the danger this presents to people living by the coast. Antarctica holds 90% of the planet's ice. And what happens there is a major influence on how much and how fast sea levels will rise. West Antarctica alone has enough ice to raise global sea levels by more than 3 meters. And this region is under threat because the mighty glaciers are changing. The largest and the most concerning is Thwaites Glacier. This glacier is the size of Great Britain and larger than the US state of Florida. The ice is over 1 kilometer thick, but it's collapsing. So, experts from the US and UK have joined forces to try and find out why. Research shows that the final point where the glacier rests on bedrock, called the grounding line, is retreating as warmer ocean water melts underneath the ice shelf. It's moved 14 kilometers since 1992. Ice that was on land has melted, or is now floating on water, and so raising sea levels. And the downward slope of the bedrock means that as the grounding line moves back, it exposes a thicker slice of ice to lift off the land, thereby accelerating the flow of ice into the ocean. In the last 30 years, the amount of ice being lost to the sea from Thwaites Glacier has increased, and with neighbouring glaciers accounts for more than 10% of global sea level rise. And if this continues, many of our major coastal cities will be under threat from more frequent and extreme flooding. So, it's vital that we take action. Reducing our emissions of greenhouse gases may delay or even prevent ice sheet collapse, but it is certain that understanding changes to Thwaites Glacier will improve projections and help governments and society to protect coastlines around the world and to adapt to rising sea levels.
Well, that is a pretty good introduction. So now let's get into this a little bit from your varied vantage points. Really appreciate your time again. Maybe we'll start with Bethan. You're in Chile. You're on the road. You're heading to a glacier shortly. You do this antarcticglaciers.org blog and website. You're focused on education, edification. So just tell us very quickly, like how you got to be who you are. What drew you to Antarctica specifically, and what's your concern here in the public sphere?
Well, I'm a glacial geologist, so there's a picture of me there in the field in Antarctica with my notebook, which is one of my main tools that I like to use, that and my camera. So I look at how glaciers have behaved in the past, and I can use satellite imagery and field work to go into the field and look at how they've responded to past climate change. So if we can work out when glaciers were bigger and how quickly they receded, and we can compare that to what the climate was doing at the time, we can start to understand the drivers and responders of past climate. I've always been drawn to Antarctica, and I was lucky enough to get a position at the British Antarctic Survey after I finished my PhD. And from there, I went off to Aberystwyth University, and I did 3 Antarctic field seasons as part of my research there. And I'm still working in Antarctica, largely using remote sensing data sets at the moment. I think the thing that draws me to Antarctica is its beauty and its importance, also its significance to global societies and global populations. And the significance is, a lot of that significance is due to its ability to really dominate the future sea level rise signature.
Right. Yeah, because of what's been clear from past cycles, as you say, too. Fantastic work. And we'll get into your sort of public communication in a minute, too. Dr. Larter, so here's this overview of aspects of this project. Can you just, give a quick sense of what's been revealed recently? We're going to talk about, the news that came out in December and what's still to come.
Well, I think to take a step back, we have to say that when we set out on this international Thwaites Glacier collaboration, there was actually remarkably little known about this part of Antarctica. Most of what was known was from satellite observations and a very few marine expeditions, because it's quite simply, it's such a remote part of Antarctica.
Right.
It takes you more than a week to get there on a ship from South America, or even longer from New Zealand. And it's a major exercise to put people on the ice there, because it's so far from the nearest permanently manned research stations, from the US base at McMurdo in the Ross Sea, or from the British Antarctic Survey research station at Rother on the Antarctic Peninsula. Either way, it's about 2,000 kilometers, which is 3 or 4 hops in the standard workhorse of transporting people in Antarctica, a twin otter aircraft.
Yeah.
The US might use some larger planes to get people halfway there to the Waste Divide, but it's still a major exercise to put people there. And recently, it's become possible because of our use of tractor trains to get a lot of the equipment and fuel that's needed for people in the field. So, I mean, in many ways, we started from scratch. I mean, when we went out on the first research cruise of the ITGC 3 years ago, there was really hardly any bathymetry data within about 50 kilometers of the front of the glacier. And we were very fortunate that field season. The sea ice was very sparse, so we were able to build up a pretty comprehensive map of the topography of the seafloor, which is important because it's the warm water masses, which are the driver of the retreat of the glaciers in this area, are dense water masses, and they flow near the seafloor. So the seafloor topography dictates where they can flow and how they get under the floating ice shelves that extend from the glacier.
Right.
There's a lot of other work we did that season. I mean, we've collected sediment cores, which we're working on. And then the following season, there was some tremendous work done on the ice shelf itself, with people drilling hot water holes, making measurements down those holes, even putting a remotely operated vehicle down there that could explore from the bottom and go right up to the grounding line. So, and that's incredibly important, because it's what happens at a small scale right at the bottom of the ice shelf. That we know that warm water is responsible for melting these ice shelves, but it's how much of that warm water really gets in contact with the ice. And there you've got to understand what's going on really at a meter and sub-meter scale right at the bottom of the ice, which you can only do by really putting instruments down these holes that are put through the ice shelf.
And I should introduce you all as doctors, seeing everyone except Jeff and I are PhDs here. Dr. Allie, Karen, what's your part in this puzzle? I know you had a paper that just came out recently too.
Yeah, so I'm on one of the ITGC teams. I was actually on the ice shelf in that second season, drilling some of those holes and doing the radar. And so I'm part of the Tarzan team. And we were kind of farther out on the ice shelf. There's another team, Melt, that was working at the grounding line. And so together we're all trying to take measurements of the details of the variations across the ice shelf. I think one of the things that really hit home for us is how complex it really is. I'm a remote sensor mostly. I mostly use satellite data for my work, and that's the recent work that came out was all satellite derived. And when you're looking at satellite imagery, especially in Antarctica, where you don't have any scale, there's no towns or buildings or anything, it's really easy to forget how big the area is that you're looking at all the time. And it kind of smooths things out when you're looking at those huge areas. And when you get onto the ice, you realize that there's so much complexity behind that as well.
It's amazing. Yeah, years ago, I was talking to some climate modelers about the Arctic, about Arctic sea ice, and efforts to model the behavior of that complex mechanism. And I started to realize that a lot of modelers, which is distinct from what you were saying, remote sensing folks, had never been to the Arctic. So they were trying to model sea ice and they hadn't seen it. And they hadn't seen the complexity and the melt ponds that form on the ice that make it hard to say what's water and what's ice. And it feels like, I kept thinking, man, there should be some kind of field trip for modelers to get out there with observational scientists. And I guess for you, it sounds like the same thing is there for remote sensing people.
So right. Yeah, no, that was my first trip to the Antarctic. And I, spent hundreds of hours looking at satellite images. And until you get there, one of the things that I look at a lot are these channels that form on the undersides of ice shelves and funnel warm water. And they leave these big depressions on the surface as the ice kind of sags in over them. And they're just beautiful in satellite imagery. They're incredibly obvious. We could just go and trace them and look at their profile change through time. And when there's a picture of me on the Dotson ice shelf there. And when we were on the Dotson ice shelf, which is just kind of around the corner from Thwaites, we really got to spend some time with a couple of these, one channel in particular that kind of bifurcates. And you can hardly even see it. Like, we put some flags out and they kind of outlined the little depression, but it's just so big. These super obvious things in satellite imagery you can hardly even know they're there when they're out there because of the scale that you're working with. And that was really impactful for me.
And Jeff, the story of ice and climate for me, and I'm sure for you for a long time, was about air temperature. The early days, the world is warming, the atmosphere is warming. Then everyone got focused more and more on heat being banked in the sea. And when you looked at it, as Karen was just saying, when you look at the details of Antarctic from underneath for the first time, you see that water makes a huge difference. The water temperature is really what drives a lot of things more than air. And what got you down there? You've been covering so many aspects of this so well, and you know how hard it is to get there. I didn't go because you have to commit a month or 2 or 3. And at the times I could never do that. So what pulled you down, and what do you see this flip in the story as?
Well, and I was beginning to report my book about sea level rise, The Water Will Come. I had been to Greenland, and as you have, and I understood what was happening up there, the surface melting and everything. And then when I started to think about, what is going to be driving sea level rise, and it immediately became clear to me that, obviously Antarctica was really important part of that. But when I first, like a lot of people, when I first, learned about Antarctica, there was this sense that, it was a cold, stable place. There wasn't a lot of sign of surface melt. It was a very different dynamic. And then I remember reading a well-known paper that everyone knows by Eric Renaud about it was satellite data showing the sort of changes in the ice sheet there. And he used this phrase that I used in my Rolling Stone piece that was published a couple of weeks ago, saying, the fuse is blown. And it captured this notion that the dynamic in Antarctica is completely different than the dynamic in Greenland. And this notion that, as you pointed out, small changes in the ocean temperature, 1 or 2 degrees, have such enormous consequences in a place like that. And it was completely fascinating to me. And, this discussion is about the word collapse, which is really interesting, I think, and word to focus on. And, in Antarctica, what fascinated me from the beginning is there is an actual mechanism of collapse. It is not a metaphor. There is a mechanism for that kind of collapse, and how it will play out and how soon it will play out and over what timescales was immediately for me, the most interesting question.
Yeah. And so this is a good time to start to focus in on the coverage and the recent flurry of attention, which has focused around one aspect of this mechanism, the dynamic there that's sometimes gets confused. It's the shelf, the glacier, the sheet. And maybe Bethan, can you walk through a little bit of that, what it means to have those components?
Yeah, these terms are they have very specific meanings in the scientific literature, but they often get confused, and people don't realize that they have very specific meanings, and they end up being used interchangeably, and that can be really confusing. We define an ice sheet as something that's overwhelming the topography. It's ice on bedrock, and it's over a specific size. That's about 50,000 kilometers squared. We only have 2 ice sheets in the world now. We have the Antarctic ice sheet, and we have the Greenland ice sheet. So although they don't really bear that much resemblance to a sheet, because they're hundreds to thousands of meters thick, they are the main dominant source of ice in our world. Then around the edges of these ice sheets, we have all these different kinds of ice, different kinds of floating ice. So there are ice shelves, which are the floating extensions of glaciers. So the Antarctic ice sheet, most of that ice terminates in the ocean. And when it reaches the ocean and it starts to melt, because it melts into the seawater, it starts to float. So around the margins of the Antarctic ice sheet, you have these floating ice shelves. They're fed mostly by ice flowing into them from the center of the ice sheet and outwards. Then around the ice shelves, we then have sea ice. So sea ice freezes and unfreezes. So it's a bit more ephemeral, and it's free floating. It will break up and move around in the summer, and then in the winter, particularly in very cold places like Antarctica, it might become fast ice, which means it's all frozen together and it stops moving around. But the sea ice is a lot more ephemeral, and it's basically just frozen seawater. So we have the ice sheet, we have the floating ice shelves, which is the landwork, the floating extensions of these glaciers, and then we have the sea ice. So we see sometimes people talking about the Arctic ice cap in the literature, which is a phrase that upsets me, because there's no Arctic ice cap. There's the Greenland ice sheet, and there's the Arctic sea ice, but there's no such thing as an Arctic ice cap.
Right. It's no, and actually, sorry, I just want to get back to the slides, because there was something that came up on Twitter that Rob was pointing to that I think starts to get us to this next phase of how do we talk about these things in a way that's effective and accurate at the same time, meaning gets attention, but doesn't gets the science right. Hold on one second. Where are we here? Share screen. Here we go. So there's been great coverage of all these issues in the media lately. I don't mean to pick on Sarah Kaplan, who does incredible work, but in her Washington Post story from the American Geophysical Union press conference, she talked about things that are really important. Total collapse of Thwaites could result in several feet of sea level rise, scientists say, endangering millions of people in coastal areas. But the piece never answers that question of what do we know about the timescale? How do we define the word collapse? I would love it if the media could make it a norm when a word that's sort of a flash word is used to just step back for a second and say, by the way, when scientists say collapse, they mean something very different than what we think of. Rob, it feels like this, this energized you. You did a string on Twitter about this. So can you talk about what your hope is?
My hope. I think it's very important that we get communication through the media right, because it's the media that is what I think senior politicians see about science. People are constantly telling us as scientists that we need to communicate our science to politicians and policymakers. And I think most scientists would say we have no idea how we're supposed to do that. There is no really formal channel. And I've just been seeing something today. One of the senior people in the IPCC is saying that she doesn't believe that most politicians actually even read the summary for policymakers, which is quite appalling as a scientist. It's right. Distilled down to make it easy for them. But I can believe that's true. I think the one thing that these leading people pick up on is things they see in the media. So it's awfully important that we get our communication through the media. So people like Jeff are in an incredibly important position to us. That the politicians are not going to read our papers even in Nature and Science. They will see things in the mainstream media. So it's important that we get that right. I'd say that's what my hope is.
And Jeff, you've dealt with this before. In your story that you wrote recently, you said you cited the fact that the doomsday glacier phrase came from your writing. It's been popped up a million times, and but at the same time, the science and your story kind of steps back and does some of these "to be sure" sentences about time scale. But what makes you excited, and then what makes you exasperated when you think about this interface between people and this kind of science?
Well, first of all, I'm in an incredibly privileged position, having gone down there and been able to spend, many hours hanging around with Rob in his cabin and on the deck, and I got a triple graduate school education, thanks largely to Rob and the science team on the Palmer when I went down there. So, I have a privileged point of view on this that I'm very, very fortunate to have, and very grateful to Rob and to others who have been so patient with me over the years. But I'm shocked by the coverage of this recent kind of press conference, and in the last few weeks. I mean, I tried very hard in my piece to balance the news with the long-term risks, and to communicate both, and to communicate risk and uncertainty in as nuanced a way as one can without losing a mainstream audience. But in talking with television producers and reading other journalism covering this with really smart people, these are not climate deniers and people who are trying to kind of trash this the whole idea of the climate crisis and stuff. I mean, really well-meaning, intelligent people got the story really, really, really wrong. And the level of sort of ignorance about basic things as Bethan was talking about, the difference between an ice shelf and an ice sheet was startling to me. And it was really a kind of wake-up call even to me about kind of how bad the media is at covering things like this and making sense of a word like collapse.
Yeah. This issue, I think, and then, what's the responsibility of the scientists to hammer this when they're being interviewed? And what's the responsibility of journalists to just say, oh, here's a word I need to think about, is a really important question. I did some work this past year with Global Press, which is an international network of female journalists in developing countries all around the world, Rwanda and Pakistan. And we were working on how to cover climate risk. And I love discovering that Global Press, if you go to globalpress.co, one of the things you'll find is their style book, like the Times and the AP. And their style book is unique because it's a living document, for one thing. And when a word is in there, like migrant, they really prompt all of their journalists who they train from the ground up to not use any word without just pausing for a minute to think about it in the context of representation, of abuse, of history. Who is a migrant, who's a refugee? There are actually legal differences there that of course, Jeff, from your book on The Water Will Rise. And I think all of these terms, I'm going to be making on my revkin.bulletin.com blog a Watchwords lexicon. So I'm going to try to sort of say, here's a word. Let's make sure we're talking about it and thinking about it for journalists or the public. And that's why I think this conversation here is sort of the kickoff for this idea. And the more we can do it, the better, as far as I'm concerned. And then getting at the sort of mixing up an ice sheet and ice shelf and a glacier is yet another iteration. I want to take us to 2014, if I can. Yeah, so this came up. There were several papers that came out that year when I think Eric was part of this with inevitability. But basically, it's all done. It's the ice sheets that matter most are unglued, and we're heading toward deep destabilization. Irreversible collapse was was the phrase. And I stepped back from my day-to-day reporting again to say, let's stop and think about this word. What do we think? And scientists were starting to clarify this, including Bethan. So here, like when you took a closer look, here's the science paper, marine ice sheet collapse potentially underway. And it says collapse in the different simulations within the range of 200 to 900 years. And it's initiation of collapse, actually. And that said to me, wow, it's actually a dangerous word without definition, because think about how that leads to either there's been this explosion of doomism, meaning, screw it, we're done, or finger pointing and anger among climate campaigners who try to make this a moment to really starkly drive home a point. The climate emergency is there on a very long time scale to me, but it's not there. It can lead to disputatious divisions, even among well-meaning climate campaigners. So all I'm saying here is, boy, I really hope that we do more of this. Bethan, I know you got at this too. So tell me what drew you into writing about the word?
I'd seen these news reports talking about collapse of Thwaites Glacier, and I'd seen that term being used very uncritically. And I think the issue is that it becomes very easy then for people to attack it, and people with an agenda
right.
to kind of say, well, no, this doesn't follow, this doesn't make sense, by this confusion about this term collapse. I mean, we talk about people collapsing, we talk about bridges collapsing, and we talk about something being very instantaneous. We talk about something that's happening very quickly. When we talk about collapse with respect to a glacier, we really mean something that's accelerating or having like a step phase change. We're talking about something that's an increasing magnitude in calving or grounding like recession. But it could, even though it's in geological time very, very quick, and in geological time it would seem almost instant, it could actually take centuries. So it's still happening much quicker, but it could still take centuries. And the confusion over this term collapse, I think it's really important for the reasons that you were just illustrating, for people to be on the same page about communicating risk and not taking this out of context. Because people might start to think, oh, we're going to have 65 centimeters of sea level rise, by 2100 or something like that. And that figure then becomes very easy for people to attack. And that then seeds doubt in people's minds, and they end up getting very confused. Where that then means you end up distrusting the scientists ultimately. So it's important that we communicate these words really, really importantly, really clearly. And so, in 2014, I started writing about this term collapse, because I had lots of people talking to me about it, and I could also see that it was getting very confused.
And there's more news coming. I think, Rob, I noticed just today, this is a British probe, I think, right? The McBoaty, what's the name for it?
So it's been dubbed as Boaty McBoatface, which was
right.
a name. There was something that was a bit like a public poll for naming our new research vessel, and that was, right. Once that got gathered some momentum, it came out way on top of it wasn't. Well, I won't go into all the details. It wasn't okay. Really supposed to be like that, but people viewed it as a public poll, and kind of a political decision was made that we decided that wasn't a name we could put on a ship and go around the world with. So the ship is named after Sir David Attenborough, which I think is fantastic, because that really emphasizes that we're putting some importance on communication of science, not just the science itself. But the name Boaty McBoatface, as a sort of to appease people a little bit, was put on this autonomous submersible, which is also a great idea, because the autonomous submersible, it's really called auto sub long range. That's what the people who work with it call it. Now gets a lot more attention, because everybody, there's so many people around the world have heard of Boaty McBoatface. So I think it's a win-win scenario.
Yeah.
There's actually several boaties, and one of them is currently on the Palmer heading for Thwaites Glacier.
I want to get back to Jeff in a second, and the science, the pull of new science. One thing we get sucked into is the new, but I want to get back to Karen and ask you if have you dealt with this issue of the pushback, around overinterpretation? How does that feel to you, Karen?
Yeah, I mean, I feel like every single conversation with anybody about this involves trying to grapple with this issue of the terminology and what does that mean, and okay, we want to balance. This is a very serious thing that we need to talk about and people need to know about, but we also need to, understand what it means in the 1 year, 5 year, 20-year timescale, as well as the longer timescale that we're working with. I really think one of the problems with this, so I'm an ice shelf person for the most part, and anytime there's a video on a news clip and about glacier retreat, it's calving of an ice front, right? You see a big piece fall off and it collapses into the water, and that is one time scale of collapse, right? And so this is something that I think very easily gets into people's minds of, okay, it's fast. I've seen it, right? Like we know it can be fast. And so that's one time scale that really does exist. But the bigger changes are then that over, little bits at a time over a very long period of time. And I think it's hard to make that transfer. In the ice shelf world, we're faster than the glacier world in many ways. So ice shelves can disintegrate, and I've kind of moved to using the word disintegrate a lot more than collapse. Ice shelves can disintegrate very quickly. So the Larsen B ice shelf in 2002, this pretty good sized ice shelf in the Antarctic Peninsula was gone over a few weeks. So again, that's a very fast time scale, but that's the floating ice. And that's one of these kind of punctuated processes that we see happening. And then when we want to think about, okay, the ice sheet and the grounded glacier itself, that's an even slower process. It's the same idea. It's the same, forcings that are mattering to this. It's the slow progress of a fast, kind of clip that you see in time. And I feel like that's where a lot of that conflict comes from, is just the images we have and the very real, pretty quick changes with ice shelves, and then trying to translate that into the volumes of grounded ice that we're looking at. Yeah.
That's a really great walk. And I do like that idea of ice shelf disintegration.
Yeah.
And then ice sheet or glacial, retreat.
Yeah. And I don't know, I don't know if
loss.
that's the answer, but I think it's a good one. And I think that's right now. Yeah, I was also very surprised at the amount of media attention that has really been continuing for a while now. There's been a lot of interest over the past couple months. And I think a lot of the flashpoint here is, as we've already said, this confusion between ice shelf and glacier. A lot of what we've been working on recently is the Thwaites Eastern Ice Shelf. So the biggest floating part of Thwaites that's left that we've been drilling through, we've got a team working on getting that right now. It is disintegrating as far as we can tell. We don't have a good time scale on that, but it's probably years, not decades. And it's not hundreds of years when we're talking about this little piece of Thwaites Glacier. But it's hard then to translate that into, okay, what does this little piece of Thwaites Glacier mean for the rest of Thwaites Glacier that really matters to sea level rise?
Yeah, again, I'm really glad we're having this conversation, because it's just, and let's hope it spills out into some newsrooms at the very least, and in the public sphere as well. Jeff, I don't know if you wrote about this paper in 2016. It really, really struck me as it was an overarching paper by Peter Clark, Susan Solomon, Ray Pierre, Humbert, and others, in which they kind of pulled way, way back. And they said, here's the Holocene, here's the Anthropocene. And what you see here, the left-hand side of the image is the last 11,000, 10,000 years. And the right-hand side is essentially the next 10,000 years. And on this scale, we're already stuck with, again, as Jeff has written in his book, and you all know as scientists, millennia's worth of sea level rise is already in the system. And those lines there, the high line there is about 40, 50 meters above today's sea level rise. The low line is a lot lower. And those are the result of different emissions trajectories. So they're basically saying, this is a simplified version of their graphic where I added those labels. What we're doing right now is choosing a sea level for the next 10,000 years. And the thing, though, that is really hard, I can't point to it here easily, is that transition point. And that's where we as journalists always focus. Journalists and policymakers do not give a hoot about the next 1,000 years, even a century from now. We want to know what's happening in the next 50 or 100 years. And that's why when you saw that phrase, collapse in the next 5 years, oh my God, that's news. And I think that's what's sustaining this news cycle. Let's hope, again, that people can append this video anytime they see that on a website, say, okay, that's the shelf. It's here. The shelf can accelerate the glacier, and that can lead to wider loss of ice. But those timescales are in centuries. And I just hope that we can figure out a way through. Otherwise, I do think what gets lost is trust, and not just lost trust in science, but trust in journalism again. We're just deepening those divides. But maybe I'm wrong. And Jeff, I don't know how to get this story on the front page or on the cover of a magazine or anything else. It's a tough one.
Yeah, I mean, obviously, writing a story about what sea levels are going to be like in 10,000 years is going nowhere with anybody. Sadly, I mean, we all wish that we had that kind of foresight about our future generations and everything, and being good ancestors and everything. But that's sort of dreamy. But I want to push back a little bit on this idea that Thwaites is a long-term risk, and that we shouldn't be focusing on the short term. And Rob and I have talked a lot about this, and he may want to weigh in. But it's really true that there's a lot of uncertainty even about the more or less near term on this. Richard Alley has talked about this extensively with me, and as he put it, I thought so eloquently, this is an event for which we have no analog. Humans have never witnessed an ice sheet collapse with the kind of physics of the ice cliff instability and things, which is a term that Rob may want to explain to people. But and Richard and others have pointed out that it, and certainly some of the modeling from Pollard and DeCanto and others have shown that even in 2100 timescale, it can have a big impact, and that is not irrelevant to how we live today. If you're thinking about re-engineering the Thames barrier, or where you're going to put a new airport in Miami, 50, 60-year timescales matter hugely. And Thwaites may indeed play a big role in that, may not. That's a tail risk, but it's certainly a risk. And I think that how to talk about this sort of near-term risk at the same time as talking about the long-term risk, and how to talk about the near-term risk without overhyping it and getting the science right, is the central challenge of the story. Well,
that gets to something you and I have written about a ton, which is exactly what you're saying. What does this mean for the mayor of Miami, or for a Marshall Islander? And to me, that takes me to the next story, which is the one the one in Water Will Rise, and I've been writing about a lot on my blog, my newsletter, whatever you want to call it. And it's what are smart things to do now with assets we have to reduce vulnerability in the face of uncertainty. But when you know that the most vulnerable people already are in harm's way, even from today's flooding, and there are these biases in how we think. There was just a piece, oh God, who was just writing about this? Oh, de Blasio. Yeah, no, it was a colleague at Columbia, the head of the Columbia Water Center, did a piece, Umanu Lal, on we're building a multi-hundred million dollar seawall project to protect Wall Street, which is a function of some of what we're talking about here, but they're not cleaning the storm drains in neighborhoods that had flash flooding that killed people. So it's like, if we hyper-focus on sea level rise, we're missing some of those other opportunities. It's the whole issue of opportunity cost and stuff, which gets beyond the realm of glaciology. But you all live in communities where these issues come up too. It's kind of a tough it's still a tough scenario. I think I want to get back one more time to where we go. Hold on. So let's just go. We have a little bit more time here. I love some of the ideas that have just come up, and maybe if each of you has an idea for one way for either a reporter or a reader or a viewer of a TV show to think differently and maybe act a little differently, what that might look like. And Karen, you're in oil country, and well, no, Alberta is more. Wait, you're in Manitoba, right? I can't remember if that's oil country.
Yeah, not really. But yeah.
No, yeah, I was off by one province.
A lot of canola oil here, but
oh, but you had the idea of disintegration instead of collapse. Anything else come to mind? And then we'll go down the chain.
Yeah, I don't know if I'm very good at, what are the individual responses. I think what I would emphasize though is that this is all one direction. So we're seeing these signs that the Thwaites Eastern Ice Shelf is going to disintegrate, and the Thwaites Eastern Ice Shelf itself is not going to raise sea level because it's floating ice. But when it goes, it's no longer supporting the ice behind it, and that may speed up and contribute more ice to the oceans. We'll see sea level rise from that. So the signs that we're seeing that might be a really rapid change. Maybe that isn't something that we should panic about right now, but it's all pointing the same way. It's all saying, okay, this is a step on the way. Right. This is something it's a here and now problem. This is happening as we speak. It's going to continue happening, and there's no signs of it going a different direction. And so I think that we grapple all the time with inevitability and with what that means for response. But I think kind of related to what Jeff was saying there, that this is something that is going to mattering now and is going to continue to matter and requires a continuous response.
Oh, actually, Jeff, the one thing I did want to bring up again was the marine ice cliff instability question, which you mentioned we haven't talked about yet. So maybe Rob or Bethan, can you give a thumbnail sketch of what that is? And it's a very new, by glaciology standards, concept, which means it's very attractive to the media. But
yeah, I can try and talk about that. I've tried to talk about it a few times over the last few years. So it's something that was only really highlighted in the science community even within the last 10 years and brought to the fore. So the fundamental point is that if you pile any material high enough, you get to the point where the weight of the material puts so much stress on the stuff at the bottom of the pile that it starts to fail.
Right.
So this is something that most civil engineers would be familiar with. They know there's a limit to how high they can build concrete before it's going to start to buckle. And it turns out that for ice in the real world, that thickness of ice above water anyhow is about 100 meters. So if you get an unsupported ice cliff that's more than 100 meters high, it's going to start crumbling. And we haven't seen this in the real world, apart from just about in a couple of places around Greenland over recent years. And though in those places, the problem with this scenario is if you collapse a cliff that's 100 meters high somewhere like Thwaites, where the bed of the glacier goes back deeper and deeper as it retreats, you collapse a 100-meter cliff, you've got an even bigger one that you've just exposed. So you've made the problem worse. So there's a definite scenario where this can run away. But I mean, people are within the ITGC. There's people making their best efforts to model this, and it's a complex problem because you have to address both the fact that ice flows like treacle and the fact it's also a brittle material that it breaks. So you've got two completely different sorts of physics you've got to bring together there. People are making their best efforts to do it, but their models quite similar to the ones that the early ones that tried to apply this process to whole ice sheet evolution. They're talking about retreat rates of a few kilometers a year. So that's our best guess of how bad it could get at the moment, I think. We can't dismiss that it could progress faster. But even so, you're still talking many decades to centuries to go back, for the retreat to go back to the middle of the West Antarctic ice sheets.
Right.
So, maybe does that fit the term collapse or not? I wouldn't say it does. But what I would like to say before we move on is I think it's the science community that's guilty for bringing the term collapse to the table. And you showed some papers from years ago that show that. And that's probably because particularly scientists who work in Antarctica, we're all familiar with looking at the long ice core records that span hundreds of thousands of years and show 100,000-year cycles. So typically a glaciation developed over about 80,000 years. Then you had a retreat over maybe 10,000 years and 10,000 years of stability before you started growing the ice again. So anything that happens within 1,000 years, you needed some sort of term to indicate that this was dramatic, and collapse is what people fixed on it. I think that's where it comes from.
And I do think, the science community wants to, I don't know any climate scientists who aren't worried about climate change. Maybe there's 2 or 3 I know, but, and I won't bring this into the funding arena, but there, organizations are eager for the spotlight. When the NSF spends money, they sent me to the North Pole. I assume they sent Jeff and Elizabeth Rush to the South Pole, and they all want to get their, the issues and their actions in the limelight. And I've dealt with this on other arenas, including the extinction of the golden toad, a frog that was linked to climate change, and then turned out it was more complicated. The initial story got huge play. Then the evolution of the story dribbled away, and now it turns out it was this chytrid fungus that's moving around irrespective in Central America to climate change on a big scale. So it's like everything's lined up sometimes to get the caricature in the foreground. And I think hopefully let's make sure that the science community is thinking about this going forward, and we can figure out some options. Bethan, I know you're dealing with both the curricular elements as education, 11 to 14-year-olds, and what's the hope at that scale? Is there some way to get them to beyond some of our own mental traps?
Yeah, I mean, I do a lot of outreach. It's not part of my job to do outreach and public engagement. I just do it because I think it's important. And I started developing these educational resources for younger age groups, partly because it's studied in school at that time, but there's not so many good resources available on Antarctica, and it's such a complicated topic. We've already talked about how hard it is for people to understand the difference between ice shelf and sea ice and glacier, let alone things like marine ice sheet instability and marine ice cliff collapse. They're just far too complex for people. And people even don't really understand the difference between sea level rise from these different sources of ice, and they get very, very confused about that. And so a lot of these resources have been very focused on just trying to get across the more basic concepts. If we can improve the scientific literacy so that people actually understand these terms a little bit more, teachers can understand them or journalists can understand them, then I think we'll be winning and making much more progress towards scientific communication. I get huge numbers of emails from outraged members of the public who accuse me of not knowing the ice floats. I get so many of them. And just trying to improve the literacy of people so that they realize that these things are taken into account and they're very precisely calculated, and we know very much exactly what ice contributes to sea level rise and in what way and where from, then I think we'll be doing much better. So I developed these story maps really to engage with teachers and to engage with this younger age group. I think they're all very interested in climate change. They're all very interested in glaciers. And Antarctica is a really great hook to engage people because it has that romance. It has that history. And so I've been developing these in order to try and bridge the gap for the next generation of scientists who I hope will be taking us forward. And that's my website there that you're just showing.
Yeah, you're doing a great job. I'm glad to encourage everyone to have a look, and you've produced some really wonderful graphics. And I love story maps as a tool. The more kids can learn how to use that technology as well, the better. We're getting toward the end here. There was a question that came in I thought was useful here. Sorry if it's blocking Bethan's face for a second. Zippy peeps. If you compare predictions from 10 to 15 years ago to the actual development, is there a discrepancy? How are we doing generally? It's really, I think journalists need to do this too, but tracking how we did and to think about going forward. Maybe very briefly, Karen.
I mean, this is another one of those things that it depends what detail you're looking in. You know, overall, is the trend going where we expected it to? Yeah, definitely. We're seeing the types of changes that we expected to see. We're learning all sorts of new things in the process. So marine ice cliff instability is maybe the most dramatic example of that, because it wasn't something that really was being included in any models 10 or 15 years ago. That's something that we're addressing now and trying to understand now. There's a lot of processes when it comes to ice fracture. It's really, really difficult to model, and it's really, really difficult to predict in any detail. So that's why when we talk about the Thwaites Eastern Ice Shelf, we say, yeah, maybe years rather than decades, but I would hesitate, I would not give you, okay, it's going to be 4 years, like that's not the level that we can be at this point, because there's just a lot of uncertainty in how to model fracture. And so yeah, I'd say that in general, there's still a lot to learn. We're narrowing in on a lot. We didn't have, even just developments in computing power. Certainly developments in the amount of satellite data that we have available to us has dramatically increased.
And the undersea stuff too.
I'm sorry. Oh yeah, absolutely. Yeah. Well, and that's brand new. And so, again, all the trends that we expect we're pretty well confirming that it's going the direction that we think it's going to go. But I would say that rather than discrepancy, there's a lot more certainty as time goes on.
And certainly about that unstoppability to a certain extent. And this generates all kinds of questions. A lot of focus is on, well, how much does emissions reduction lower that risk? It's a fat tail risk, as Jeff was saying. I mean, it's the end of the tail. I think the level of unknowability there is sufficient that we can operate on a basic principle, which has been the IPCC's message forever: rising risk with rising emissions and rising temperature. But we as journalists, we get seduced by the new. The marine ice cliff instability was new. We give it a lot of attention. It has scare factor. It has page one pull because it's new, because it's contentious. Tamsin Edwards did a pushback paper on it, which takes me back to basic principles. And that's why, as a journalist, I'm spending less time doing journalism, more time doing this kind of thing, to see what I could do as a communicator to foster some somewhat better outcomes, not by trying to convince people with a new story, but trying to engage people who might not talk to each other and think about things in different ways. It's great that you've all been here. Jeff, just a last thought from you too on where do we go from here as journalists might be good. And thank you all for being here today.
Well, it's a privilege to be here, Andy, and talking with you. I mean, you are, you are one of the pioneers in climate journalism. You've been at this longer than anybody else. But, for me, 20 years ago when I started writing about this, it was like talking to people at, dinner parties and stuff about climate journalism. It was like talking about the sort of sex life of porcupines. It was like, oh, that's cute that you do that, But now it's changed a lot, right? Everyone knows. I mean, we see the wildfires, shopping malls burning in Colorado in the middle of winter. And, there's this huge disconnect between how fast this is all playing out and how educated we are as journalists and human beings about what's going on. And I don't think journalists and the media have come close to sort of answering the call of this. I mean, there's just nowhere near enough resources, interest, it's just commitment to this story, and it's beginning to happen now, I think. And I think that one of the things we saw with this Antarctica story is a lot of kind of inexperienced journalists trying to grapple with ice sheets and all that kind of thing. And so there's this upsurge all of a sudden. We have movies like Don't Look Up, becoming big phenomenons. I think that there's a cultural change happening, but we as the media and journalists and scientists in communicating are still behind the curve.
I agree. So let's just keep working at it. If you could all come back on sometime, that would be great. So this is this Watchwords project. I've set up a link there for people to send their ideas for words they think are misinterpreted or have multiple meanings. You can see their attribution. There's lots of questions. Existential risk. What do we mean when we say existential risk? How much does climate emergency hide? Oh, well, one I've just been talking about is the idea that no one is safe. We could have a whole hour on that because there's so many people who are deeply vulnerable because of poverty and prejudice. And for us who are truly privileged, including all of us here, anyone sitting in a room with climate control and access to technology is not at risk, the scope that someone in a Durban, South Africa slum is from flooding. So there's lots of discussions to have. The more we can zoom in on these words, today's being collapsed, the more we can perhaps have civil, constructive conversations and build both a safer climate and a safer and more productive communication climate. So thanks again to Bethan, Davies, and Chile, University of London, Rob Larter from British Antarctic Survey, Karen Alley from University of Manitoba, Jeff Goodell down. Are you in Austin? Sorry, you're muted, but
yes, I'm in Austin. Yes,
you're missing our Hudson Valley snow.
Yeah, I know. It's 80 degrees here today. But
I love Austin too. So thank you all for being here today. If you could stay on for another minute, I'm going to play Karen Alley video going out because we all need to stay sane too. And I'm glad, like I do, Karen uses music as a way to shift gears. But if you have to leave, feel free to check out and come back though, and we explore some more watchwords. So here we go. Let me see if I can find it. While I'm setting that up, if anyone has a last thought, feel free. Here we go. Thank you, Karen.
Thanks, Andy.
Thanks, everyone. And have a good, productive, healthy, safe year despite everything that's going on. Take care.
Thank you.